So let us understand the problem. Suppose it is told that a man has fallen into a ditch of width d. You can see it in the figure. Two of his friends are slowly pulling him out using a light rope. Okay, this rope is light and they are slowly pulling him out. Okay, and the two fixed pulley as shown in figure. So these are the pulleys that are actually fixed. The things they require is like show that the force assumed equal for both the friends. That means whatever force this person is, this friend of him is pulling, with similar force this person is also pulling, right? And at the end we have to prove that the force exerted by each friend on the rope, it will be rope, force exerted by each friend on the rope increases as the man moves upward. So as this person moves upward, the force, that means H, if H actually reduces, if suppose you call it as you call it as H, if this H reduces, then this force required to pull will be more. That is what actually the target of this question. Let us see what are the assumptions under which we will solve the problem. First assumption is the light rope. What is meant by light rope? When the mass of the rope is much less compared to the mass that other masses there in the system, like the mass of this person M, or maybe other masses if it is given in a problem. So this actually meant that the mass of the rope is much smaller compared to the other masses in the system. Now let's move on to the next assumption. Next assumption is slowly pulling him out using a light rope. Now let's understand this concept. What does actually mean? Suppose we have a mass M, of mass M. We are pulling it by a force F and it is placed in a vertical direction, so there will be gravity acting. So due to this there will be a force mg that is acting downward. Now if you pull this force and it is moving upward, then as you know, the net force in the body, that is F minus mg, will be responsible for the acceleration of the mass. This is the mass, this is the mass, and it is having an acceleration. Now what is acceleration? Acceleration is dv dt. Okay, now if dv dt becomes 0, that means this acceleration of the system will be 0. So then we can write F equal to mg. Now we will understand under what condition dv dt can be 0. First case may be when velocity is constant. Over time the velocity is not changing, then we can appreciate that. Other way, like as we know, we can define velocity as delta t tending to 0 delta v by delta t, like the rate of change of velocity. Okay, then we can think it like that. Suppose I take the time change as the time frame over which the velocity is changing as like 0.01, and the velocity change which happens over this time frame is 0.00001 and you divided by 1. So whatever value you come across is very small. Okay, so what I am trying to say is, suppose there is a block which is moving up F and the gravity force is mg. Now it is moving very slowly, so F minus mg is actually m into a. But if this acceleration, because as you know this quantity will be very small, it is not 0 but it is very small. so it will be tending to 0. So then we can say F is almost equal to 0. Okay, as if every time whenever you are seeing it, you will just perceive it as it is in rest. Okay, that is the importance of this assumption, what is mentioned in this problem, that is his friends are slowly pulling him out using a light rope. As if every time whenever you see this person, you will see that, you will perceive him that he is at rest. Okay, that means there is no acceleration for that person. Now we will see that how this problem can be perceived in terms of all the dimension that is given in the problem. Okay, now this is the person which is having a mass, suppose m. Okay, and these are the two person which is pulling at equal forces F, and this is the dimension which you know that this dimension is h. Okay, now the first thing that we have to really remember is that we have to draw the free body diagram of this mass, because our target for this problem is to find out, as this is going up, as the height of this is decreasing, as the height of it decreasing, that means the height is decreasing, as it is going up, the force required will be also less. That's what the whole idea, that what we can really say. Now this idea is that as you are decreasing this h, this force will be increasing. That's what our one of the target is. And next we have to really quantify the force, which will be a function of this h. At the height h, how will you relate this force and with the help of the given parameters of a problem, like the dimensions that are given, like this is d by 2, that you can find out, and probably this height h, which is also given to you. Now we will try to solve the problem. That's the whole idea. Now half of the problem is done. Now we will try to see the geometry of it. So you can see this is the man which is having a mass m, and these are the two persons who is pulling with F forces, and both are same. That's what it is given in the problem. But another assumption which is there, that is that here the pulley is frictionless. So as this pulley is frictionless, then under that condition we can really think F is equal to the tension that is there in the string. So if you cut anywhere at that point, if you see that on one side you have force, on other side you have tension, and tension acts away from the body when you are drawing the free body diagram of a rope. Okay, but similarly if you try to draw the free body diagram of the mass, then you can typically see, suppose this is the mass, you have two forces which is acting, as the pulleys are frictionless, and at the same time you have a mass mg acting vertically downward. Okay, now as the geometry was given like d, which is the width of this pit, and d and h is the height. Suppose we take the height is something as h at any particular time or at particular instant. If you typically see that h is the height of that mass from the person who is actually pulling, Now if you, from this diagram, if you typically see that there is two component which is acting in this direction, F sine theta and F sine theta, which is actually balancing each other. But the only thing is that, as we have appreciated, that in this system it doesn't have an acceleration, right? So the delta F, that means that net forces in the y direction will be 0. Okay, so that is one of the important things you have to remember. So 2f cos theta, if the component in that direction, if you project this f in this direction, it will be f cos theta. Now similarly for this, so f cos theta. So if you add these two, then you are getting 2f cos theta. Okay, now that will be balanced by mg. That's what we have get. Okay, from this we have mentioned f equal to mg by 2 cos theta. Now what is cos theta? If you typically draw this triangle like this, if you just elaborate that in this figure, you can typically find this is 90 degree. It's a right angle triangle, and by Pythagoras theorem you can find out the relation between the hypotenuse, base, this base, and the perpendicular, what we call as. Okay, now you can find out by just doing hypotenuse is basically what, h, which is h square, that will be equal to, because this is not given, the thing which is not given is the hypotenuse, that you can calculate. That you can calculate by what? The hypotenuse will be perpendicular square plus base square by root times. Okay, that is how we know the Pythagoras theorem. A square equal to b square plus c square, where a is the hypotenuse, b is the base, and c is the perpendicular, that distance. Okay, now following this formula we get the value of cos theta, and we put it in this expression. When we put it in this expression, little bit of bringing this h to the down, then what will happen? If you take this h into this root inside, then it will be typically take this form, and once you have this, you can typically arrive at a condition of this position by just playing this thing around. Okay, now as you can see, if you increase this h, this quantity will what? This quantity will decrease. Okay, so overall the force will be increasing. On the other hand, if you typically decrease this h, then definitely this will increase, so ultimately the force will increase. That's what actually told to prove in the problem. Okay, that we have already understood. At the same time, it also told to find out the force. Okay, so that also we have found out, and this is the expression typically. But the whole idea we have to really understand what are the assumptions under which it came. That is very important. If you are trying to do different type of problem, this type of assumptions you have to remember in mind. So this is what the strategy you should adapt for solving this kind of problem. Just to add at the end, the things you need to remember, like the Pythagoras theorem, because that will relate the hypotenuse with the base and height. If either of the two is given, then using this two you can calculate the other one, right? Like height and base, if it is given, you can calculate the hypotenuse. If base and hypotenuse is given, you can calculate the height. Similarly, other unknowns can be calculated. Okay, now once you find out all those whatever three known thing, and using that dimensions, you can calculate the cos theta, because while computing, if you require these trigonometric functions like cos theta, sin theta, or tan theta, then definitely you can use this to get this. Like cos theta will be what? Base by hypotenuse. Sin theta will be what? Perpendicular by hypotenuse. Similarly, tan theta, if it arrives, then it will be perpendicular by base. So these things you have to remember at the end. Thank you.